Tonight, we are going to talk about a star that may already be living through its final chapter, even though it still shines peacefully in our sky. Betelgeuse sits on the shoulder of Orion, glowing red and unstable, a massive supergiant near the end of its life. From Earth, it looks like a familiar winter star, something ancient and calm above the night. But in reality, it is a dying sun so enormous that its future ends not with a quiet fading, but with a supernova. The terrifying part is not that it will destroy Earth, because it is far too distant for that. The terrifying part is time. If Betelgeuse exploded tonight, the light we see would not be happening now. It would be an old event finally arriving from a star that may have changed centuries before we knew. So tonight, the question is simple. What would really happen if Betelgeuse exploded tonight? Before we begin tonight's journey, subscribe if you want more calm space documentaries like this. Leave a like if you enjoy deep space mysteries, and write in the comments where you are watching from. Tonight, you are watching the Just About Space channel, talking about Betelgeuse could explode tonight. And it's terrifying. Somewhere in the winter sky, in one of the most recognizable constellations humans have ever named, there is a red point of light that looks calm only because distance makes violence appear peaceful. It sits on Orion's shoulder, easy to find if you know where to look. Below it are the three stars of Orion's belt, almost perfectly lined up like a mark drawn across the night. Around them, the shape of the hunter rises above the horizon, a pattern so familiar that generations of people have looked at it and given it stories, names, gods, seasons, and meanings. But the red star on the shoulder is not only part of a pattern, it is not only a decoration in a human constellation. It is a dying supergiant, enormous, unstable, and nearing the end of a life so different from the sun's that it almost belongs to another category of reality. That star is Betelgeuse. From Earth, Betelgeuse can look gentle. It does not flash like lightning. It does not roar. It does not visibly shake the sky. It appears as a small reddish light among other stars, sometimes brighter, sometimes dimmer, but always distant enough to feel safe and almost ordinary. A person can walk outside on a cold night, look toward Orion, see that red shoulder, and return home without feeling that they have looked at a star living near catastrophe. For thousands of years, people have seen it without knowing what it truly was. Ancient observers did not know about stellar evolution, nuclear fusion, red supergiants, mass loss, or supernova cores collapsing in the final moments of a massive star's life. They saw a red star in Orion and wove it into the sky culture of Earth. And in a way that was still appropriate, because Betelgeuse is a story star. It is the kind of star that seems to ask for myth, not because myth explains it scientifically, but because its real nature is almost too large to hold in ordinary thought. It is a star so large that our sense of scale begins to fail. It is a star so unstable that even its brightness has become a source of global attention. It is a star close enough to be familiar, but far enough away that everything we see is already old. That last detail is what gives Betelgeuse its particular kind of terror. The red light reaching our eyes tonight did not leave the star tonight. It crossed space for centuries before it touched Earth. When you look at Betelgeuse, you are not seeing a present moment in the simple human sense. You are seeing history arriving as light. The star you look at is always the star as it was, not necessarily the star as it is. It may not threaten our bodies. It threatens our sense of time. Because if the explosion ever appears in our sky, the actual event will not be happening then. The collapse, the blast, the tearing open of the star, the release of light and material, the beginning of the supernova remnant, all of that would have happened long before the first person on Earth looked up and noticed the change. We would not be watching a star die live. We would be receiving the news after centuries of travel. The universe has no breaking news in the human sense. only delayed light. This makes Betelgeuse feel almost like a message already in transit, except we do not know what the message contains. Tonight, the light says the star was still shining when that light left. Tomorrow night, the light will say the same thing about another moment from the past. But somewhere beyond what we can see directly, the star's true present remains hidden by distance. It could still be there, swollen and unstable. It could remain there for ages. Or in the most haunting version of the thought, it could have already changed, and the evidence simply has not arrived. And distance is what makes the red star on Orion's shoulder feel so strange. Betelgeuse is close in cosmic terms, close enough for astronomers to study its surface behavior in remarkable ways. Close enough to be one of the most important red supergiants in the sky. But it is still so far away that its presence is locked away from us. The star is familiar and unreachable at the same time. This combination is what gives the opening of the story its mood. The sky becomes more terrifying the more precisely we understand it. Not because knowledge removes beauty, but because knowledge adds depth to beauty. Betelgeuse is more beautiful when you know it is unstable. More haunting when you know its light is old. More meaningful when you know that every calm night it appears above Earth, it is also moving through a final stage of stellar life. Not a panic, a slow look. Imagine standing outside at night, with the air cold enough that the stars feel sharper. Orion is rising, or already high in the sky. The belt is easy to see. Around it, the outline of the constellation forms itself almost automatically in the mind. And there, on one shoulder, is Betelgeuse, glowing with a reddish-orange color that sets it apart from many of the colder-looking stars around it. It looks small, because everything beyond the solar system looks small from here. But that smallness is a trick. The point of light is not the thing. Of course, a star does not breathe like a living creature. But the metaphor helps the mind feel the motion. Betelgeuse brightens and dims. It swells and shifts. Its surface is not a hard boundary like a planet's surface. It is a deep, restless envelope of hot gas, convective cells, magnetic activity, dust, and material escaping into space. Even saying surface can be misleading, because a star like this is not a solid object with a clean edge. It is a gigantic atmosphere around a nuclear heart that is running out of the easy ways to stay stable. That explanation is not disappointing. It is actually more intimate. It means we did not simply watch a random change in brightness. We watched a dying star cough material into space. We watched part of its outer life become visible through a shadow. The dimming was not the supernova, but it showed that Betelgeuse is not static. It reminded the world that the star is alive in the stellar sense, changing, unstable, and capable of surprising us. For a short time, Betelgeuse stopped being just one star among many. That does not mean the final explosion is likely tonight. It means the star belongs to a category of objects whose ending is known in principle, but unknown in timing. We know the kind of fate awaiting it. We do not know the date. That uncertainty is what makes it so compelling. A predictable ending with an unpredictable schedule creates a special kind of suspense. The star is doomed. But the clock is hidden. This hidden clock is one of the most important ideas in the entire video. Betelgeuse is not like a bomb with a visible countdown. It is more like an enormous dying furnace whose interior has entered stages we can understand only indirectly. Deep inside, the star's core is moving through the late phases of nuclear burning that massive stars experience before collapse. But from Earth, we cannot look into the core directly. We read the surface, the brightness, the motion, the atmosphere, the dust, the models, and the clues. And when it does, the sky will tell us after the fact. This is the kind of thought that belongs to a calm space documentary, because it is both peaceful and unsettling. Nothing in the night sky seems hurried. Orion rises slowly. Betelgeuse glows calmly. The seasons turn. People live their lives beneath the same patterns their ancestors saw. But inside that calm is a hidden instability. One of the stars in the pattern is not a permanent ornament. It is a massive dying object whose final act is somewhere ahead of us in observation, even if it may already be behind the star in reality. What is visible to us is light arriving now. What is true there is whatever Betelgeuse is doing now, hundreds of years after that light left. Those are not the same thing. For nearby human events, this difference is too small to matter. When someone turns on a lamp across a room, the light delay is almost nothing to us. When the sun shines, its light is about 8 minutes old, and even that is easy to understand. But for Betelgeuse, the delay becomes historical. The star we see belongs to another century. We are always watching an earlier version. That makes every observation slightly ghostly. The red shoulder of Orion is not just a place. When you look at Betelgeuse, you are seeing a moment that began before you were born, before your parents were born, before modern life looked the way it does now. The photons have traveled through darkness for generations, crossing the space between stars until they entered the atmosphere of Earth and reached your eyes. The star feels present because the experience happens now, but the event itself is old. Betelgeuse turns seeing into remembering. This is why the idea that it could explode tonight is so strange. If we saw it brighten tonight, the explosion would be tonight for Earth, but not for Betelgeuse. For the star, the death would have happened long ago. The sky would be giving us an old catastrophe as a new experience. A supernova would therefore be both a present event and an ancient one, depending on where you stand. On Earth, the night changes. At the star, the change is history. That duality is terrifying because it reveals how local human time really is. We say now as if the universe shares a single clock with us, but across interstellar distances, now becomes slippery. Betelgeuse teaches that the universe is not only separated by space, but by delayed knowledge. We live inside a bubble of arriving information. The sky is not a live screen, it is an archive of light. And Betelgeuse is one of the brightest pages in that archive. So the first chapter begins with a simple act, looking up. Before we talk about how Betelgeuse differs from the sun, before we talk about its size, its dimming, its eventual explosion, or what the sky would look like if it became a supernova, we have to let the familiar star become unfamiliar again. We have to take the red point on Orion's shoulder and remove the comfort that distance gives it. It is not just a star in a constellation. It is not just a name in astronomy. It is a dying giant whose light reaches us late. And because of that, Betelgeuse is one of the rare objects in the night sky that can make the future feel as if it may already have happened. The next time someone sees Orion, they may not think of the hunter first. They may think of the red shoulder, the unstable star, the ancient light, and the possibility that somewhere beyond what we can currently see, the star's final chapter is already written. That does not mean we should expect the sky to change tonight. It means the sky carries more uncertainty than it appears to carry. Betelgeuse is calm only from far away. Up close, it is something else entirely. And to understand why that red point is so unstable, we first have to understand why Betelgeuse is not like the sun. At first, that may sound obvious. Betelgeuse is a red supergiant, and the sun is the star that warms Earth every day. One is distant, red, swollen, and unstable. The other is familiar, yellow-white, steady, and close enough that its light shapes every living thing on our planet. But the difference between them is not simply size or color. It is not just that Betelgeuse is larger and the sun is smaller. The deeper difference is in the way they live, the way they burn, the way they age, and the kind of ending waiting for them. The Sun is a long-burning star. Betelgeuse is a fast-burning giant near the end. The Sun is not perfectly calm. It has flares, magnetic storms, sunspots, eruptions, cycles, and a powerful solar wind. It can disturb satellites, power grids, and auroras on Earth. But compared with a massive star near the end of its life, the Sun is controlled. It is held in a long balance between gravity pulling inward and energy pushing outward. Gravity tries to crush the star. Fusion in the core provides pressure that resists that collapse. As long as the balance holds, the Sun remains in the long central phase of its life. Betelgeuse has lived by the same basic battle, but at a completely different scale. Gravity pulls inward, fusion pushes outward. But massive stars pay for their brightness with time. This is one of the strangest truths in astronomy. A star with far more mass than the Sun does not simply live longer because it has more fuel. It burns its fuel much faster. Its core is hotter, more intense, and more pressured. Fusion happens at a furious rate. The star shines with enormous power, but that power comes at a cost. The fuel disappears quickly by stellar standards. The Sun can live for billions of years. This is why the star feels so unsettling. It is young, but dying. It is huge, but fragile. It is bright, but unstable. The Sun's future will be strange, but it will not end as a supernova. Our star does not have enough mass for that. One day, billions of years from now, it will expand into a red giant, transform the inner solar system, shed outer layers, and leave behind a white dwarf. That ending will be enormous for Earth, but it is not the same kind of death that waits for Betelgeuse. The Sun's death is slow, swelling, and quiet compared with the collapse of a massive star. Betelgeuse belongs to a more violent family. The core loses the battle. Gravity wins. From Earth, that difference hides inside one red point. The sky compresses the truth. The Sun fills the day with light. Betelgeuse occupies a tiny place in the night. Human instinct might assume the Sun is the more important, more powerful, more real star because it dominates our experience. And for life on Earth, it is. But Betelgeuse is far more luminous, far larger, and far more dramatic in its final evolution. It only looks small because distance has reduced it to a dot. Distance makes the Sun feel personal. The Sun is personal because we live inside its influence. Every plant, ocean current, weather pattern, season, and biological rhythm on Earth is tied to it in some way. It is the star that allowed our planet to become a living world. Betelgeuse has no such direct relationship with us. It does not warm our skin. It does not decide our seasons. It does not hold Earth in orbit. It lives far away, in Orion, separated from us by hundreds of years of light travel. But scientific importance is not the same as personal importance. Betelgeuse matters because it lets us study a kind of future the Sun will never have. It gives us a nearby example of a massive star near the end of life, a star swollen and unstable enough that its behavior can change in ways people can notice. It is not nearby in human travel terms, but it is nearby for a red supergiant. That makes it one of the great laboratories of stellar death in our sky, a laboratory that looks like a star. The color alone tells part of the story. Betelgeuse appears red or orange because its outer layers are much cooler than the Sun's visible surface. Cooler, here, does not mean cold. It means cooler compared with other stars. The star is still unimaginably hot by human standards, but its outer envelope has expanded so much that the surface temperature is lower and the light shifts toward redder colors. The Sun's light appears much whiter and warmer to our eyes because it is a different kind of star in a different phase. Color is not decoration in astronomy. The star is changed. The star is late in its story. The star is no longer living the way it once did. The Sun by contrast, is not late in that way. It is still burning hydrogen in its core in a long, steady stage. It will change, but not soon by any human scale. It will not become a red giant tomorrow, or in 1,000 years, or in 1,000,000 years. The Sun's future is vast and slow. Betelgeuse's future is uncertain and much closer in stellar terms. That difference makes Betelgeuse feel like a star with a hidden cliff ahead of it. The cliff may not be at our feet, but it exists. For the Sun, the date is so far away that it belongs to a different kind of imagination. For Betelgeuse, the uncertainty feels closer, even if the explosion may still be thousands or tens of thousands of years away. This is why it occupies such a strange place in human thought. It is not an imminent danger, but it is a real future event. It is not likely to happen tonight, but if it did, the sky would change in a way every person on Earth could understand. A star would become a supernova. A familiar constellation would lose its shoulder. The night would gain a new brightness from an old death. This is where Betelgeuse becomes emotionally different from the Sun. The Sun's future is bound to Earth's far future and the slow transformation of our own planetary home. Betelgeuse's future is a spectacle from afar, a death we could witness without being destroyed by it. It is the rare cosmic disaster that may be safe enough to watch. That safety makes the thought even stranger. We could see the death of a giant star while standing outside our homes, looking up from streets, fields, mountains, rooftops, and quiet windows. No heat, no shockwave, no sound. That is the nature of distance again. It protects us and separates us at the same time. If Betelgeuse were close enough to threaten Earth, it would be a different kind of story. But because it is far away, its eventual supernova becomes a visual and scientific event rather than an extinction event. The terror moves from survival to meaning. We are safe enough to understand how small we are. And understanding smallness is its own kind of fear. The Sun makes us feel centered because it is the center of our system. Betelgeuse makes us feel displaced because it reminds us that other stars live and die according to scales that have nothing to do with human life. The Sun is the star that gives us time. Betelgeuse is the star that shows us time can be enormous, violent, delayed, and indifferent. One star is the clock of our days, the other is a clock we cannot read. This comparison is not meant to make the Sun seem ordinary in a dull way. The Sun is extraordinary. Without it, there is no Earth as we know it, no oceans in their present form, no living atmosphere, no green world, no human eye looking at Betelgeuse in the first place. The Sun is the reason we can ask these questions. But Betelgeuse reveals something the Sun cannot: the life of a star that spends itself quickly and ends in one of the universe's most powerful explosions. Together, they show that not all stars are variations of the same gentle light. Some stars live slowly, some live violently, some become long-term homes for planets. Some burn too bright to last, some die quietly, some tear themselves open and seed the galaxy. Betelgeuse belongs to that last kind. A massive star like this does not only die for itself. When it explodes, it throws material into space. Elements forged inside the star are released outward. The death becomes part of the galaxy's future chemistry. Supernovae are destructive, but they are also creative in the deep history of matter. They help distribute the ingredients from which later stars, planets, and perhaps life can form. That makes Betelgeuse not only a dying star, but a future contributor to something else. The Sun, too, belongs to a cycle of stellar material. The atoms in Earth and our bodies came from earlier generations of stars. But the Sun will not create a supernova blast that scatters heavy elements across the galaxy in the same dramatic way. Betelgeuse will. Its ending will be violent, but not meaningless. It will be part of the cosmic recycling that makes complex matter possible. This is one of the reasons supernovae feel so profound. They are endings that become beginnings. The star dies, but the material continues. A giant collapses, but the galaxy receives what it made. That thought changes the feeling of Betelgeuse. It is terrifying, but not only terrifying. It is unstable, but not pointless. It is doomed, but its doom belongs to the larger life of the galaxy. The same processes that make the star frightening also make it important. It is a furnace approaching failure, but the failure will release what the furnace has made. That is very different from the sun's quiet future. The sun will eventually become beautiful in another way, shedding its outer layers into space and leaving a white dwarf behind. But it will not announce its end with a visible supernova. Betelgeuse will, if current understanding of its nature is correct. It will end with a flash of cosmic violence bright enough to reach Earth as one of the most remarkable sky events humans could ever witness. And yet, even that future is hidden inside the present red dot. This is why the second chapter has to slow down around the difference. Without understanding how unlike the sun Betelgeuse is, the title sounds like exaggeration. A star exploding tonight sounds like a random disaster. But once we understand the kind of star Betelgeuse is, the idea becomes less random and more haunting. It is not any star. It is a massive red supergiant near the end of its life. It has already left the calm middle stage behind. It is unstable because massive stars become unstable as their interiors approach the final stages. The sky gives us a red point. Physics gives us a dying giant. And time gives us uncertainty. That combination is why Betelgeuse holds so much power over imagination. It is visible, without a telescope. It belongs to a famous constellation. It is far enough away to be safe. It is close enough to matter. It is known to be dying. It is unpredictable in timing. It is not like the sun. And that difference is everything. When you look at the sun, safely through filters or indirectly through daylight, you are experiencing the star that keeps Earth alive. When you look at Betelgeuse, you are seeing a star that reminds Earth what stars can become. One supports life over billions of years. The other races toward a brilliant death. And both are real stars, obeying the same laws of physics, but living under different masses, different pressures, and different clocks. That is the beauty of stellar evolution. It is not one story repeated endlessly. It is many possible lives depending on mass. A star's mass at birth is like a first sentence that determines much of the story that follows. The sun's first sentence led toward long stability. Betelgeuse's led toward speed, expansion, instability, and supernova. Mass is destiny for stars. Not completely in every detail, but deeply enough that the entire emotional difference begins there. Betelgeuse was born massive enough to live fast. The sun was born modest enough to live long. That is why one can support a stable planetary system for billions of years, while the other becomes a red supergiant in a much shorter time. The stars are not choosing different fates. Their physics writes those fates from the beginning. This makes the night sky feel stranger. Every star you see has a hidden biography written in its mass, temperature, composition, and age. Some are young and blue. Some are old and red. Some are quiet like the sun. Some are giants. Some are already dead, but still sending light. Betelgeuse is one biography near its dramatic final chapters, and because it is bright and familiar, we can point to it and feel the story directly. The red point is not a decoration. It is a life stage. A late chapter of a massive star written across the night. And once we understand why Betelgeuse is not like the sun, the next thing to imagine is how a star can swell into something so enormous that it becomes almost impossible to picture. This is where ordinary scale begins to fail. When we say Betelgeuse is huge, the word huge does almost nothing. It is a human word built for mountains, buildings, storms, ships, cities, and planets seen in pictures. It can stretch a little. It can hold the size of Earth, perhaps the size of Jupiter, perhaps even the size of the Sun, if we are used to thinking in astronomy. But Betelgeuse asks the word to hold something far beyond everyday imagination. It is not simply a large star. It is a swollen red supergiant, a star that has expanded until its outer layers reach across a volume so vast that the mind keeps trying to turn away from it. The Sun already feels enormous. Earth is more than 1,000,000 times smaller than the Sun by volume, and yet from the ground, the Sun appears as a bright disk, small enough to cover with a thumb held at arm's length. That alone is strange. The star that controls our daylight, seasons, weather, and biological rhythms appears small because it is far away. But Betelgeuse is larger still, so much larger that if it were placed where the Sun is, the familiar order of the inner solar system would no longer feel familiar at all. Mars, too, might be swallowed or placed near the outer edges of the star's extended atmosphere, depending on the exact size Betelgeuse has at that moment. Because red supergiants do not hold a simple fixed edge the way a solid planet does. The star's outer layers are diffuse, enormous, shifting, and hard to define with the clean geometry humans prefer. Even saying where the star ends becomes more complicated than drawing a line around a sphere. That is part of what makes Betelgeuse so hard to picture. We want stars to be balls. Betelgeuse is more like a vast, unstable atmosphere around a dying core. It has no solid surface to stand on, no sharp boundary where one could say the star stops and space begins in a simple way. It is a deep envelope of hot gas, thinner in its outer regions than the star appears in imagination, but still part of the swollen body of the red supergiant. The outer layers breathe, shift, pulse, cool, warm, and lose material. Betelgeuse is not only big, it is big in a loose, restless, unstable way. And yet, from Earth, it remains only a reddish light. That is the cruelty and beauty of distance. Something large enough to reshape our sense of scale becomes small enough to fit between other stars in a constellation. Children can point at it. People can mistake it for just another star. The human eye receives a tiny spark from a stellar body that could engulf the inner solar system if it sat in the Sun's place. Distance makes monsters gentle, but the monster is still there. To understand why Betelgeuse became so large, we have to return to the life of a massive star. During the long, stable part of a star's life, fusion in the core creates the outward pressure needed to resist gravity. But when a massive star begins to exhaust the hydrogen in its core, the balance changes. The core contracts and heats. New layers of fusion can ignite around it. The outer parts of the star respond by expanding outward into space. The star grows cooler at the surface, redder in color, and vastly larger in size. This swelling is not calm from the inside. It is the visible result of deep instability. It is what a massive star can become when it has left the simplest part of its life behind. This is important because size here is not a sign of health. In human terms, growing larger can sound like becoming stronger. For Betelgeuse, the swelling is part of decline. The star is not expanding because it has more future ahead of it. It is expanding because its internal life has become more complicated, more unstable, and closer to the conditions that will eventually lead to collapse. Its enormous size is not youth. It is old age in the life of a massive star. A red glow, a famous name. This is not a world. It is a star expanded into a realm. The word realm matters because Betelgeuse is so large that it forces us to think spatially rather than visually. A planet is a place. A star like Betelgeuse is also a place in one sense, but not a place for surfaces, horizons, mountains, or ground. It is a place made of plasma, radiation, convective motion, gravity, heat, and material rising and falling in scales that dwarf planets. If the Sun is already beyond human bodily experience, Betelgeuse is beyond the Sun in a way that feels almost unreal. And still, it is real. The imagination struggles because reality is larger than imagination. This is why astronomers use comparisons, even though every comparison fails. We compare Betelgeuse to the Sun because the Sun is our familiar star. We compare its size to planetary orbits because orbits give us a structure we can visualize. We compare its age to the Sun's age because time needs contrast. But each comparison only brings us close to the edge of understanding. Betelgeuse remains too large for the mind to hold steadily. The same point of light becomes a cosmic structure. Betelgeuse also teaches that stars are not fixed objects in the way they appear from Earth. The night sky feels still because human lifetimes are short and stellar distances are enormous. But stars are evolving. Betelgeuse is not the same star it was millions of years ago, and it will not remain the same in the future. Its current swollen state is temporary, even if temporary for a star may still feel long to us. The red supergiant phase is a late chapter, not a permanent identity. That makes the size even more dramatic. It is not only enormous, a slow catastrophe in stellar form. The word catastrophe does not mean something bad for us. It means a dramatic transformation, a breaking of an old state into something new. Betelgeuse's swelling is already part of that transformation. The star has changed from what it once was into something too large and unstable to last. Long before the supernova, it has already become a sign of stellar mortality. This is where the comparison with the Sun returns. The Sun will one day swell too. Billions of years from now, it will become a red giant, and that future will transform or destroy the inner worlds as we know them. But the Sun's swelling belongs to a slower, lower mass path. Betelgeuse is a more massive star moving toward a more explosive fate. Both stories show that stars evolve, but Betelgeuse shows the violent version, the version where enormous size becomes the prelude to collapse. This is why the visual image matters so much. If Betelgeuse were placed at the center of our solar system, the familiar map would become almost meaningless. We normally imagine the planets orbiting in clean, dark space around the Sun. But with Betelgeuse there, the inner solar system would be inside or near the envelope of a dying star. The idea of Earth's orbit as a safe path becomes impossible. The blue world would no longer sit in daylight. It would be swallowed by a red stellar environment beyond human survival. Again, this is not a threat, because Betelgeuse is not where the Sun is. And scale teaches humility. Earth feels large from Earth. Continents feel large. Oceans feel large. The distance to the moon feels enormous. Even Mars feels impossibly far away for human bodies. But compared with Betelgeuse, the inner solar system itself becomes small. The distances that define our planetary neighborhood become part of a stellar body. That is one of the most mind-breaking facts in this video. The home system can become a measuring unit for another star. This is the kind of fact that should not be rushed. It needs space to settle. The viewer should feel the map expanding, then collapsing. The Sun at the center. Mercury, Venus, Earth, Mars. The familiar orbits. Then Betelgeuse placed there, not as a small red dot, but as a vast glowing atmosphere that reaches across those orbits. Suddenly, the solar system feels fragile. The safe distances feel temporary. The scale of stars becomes almost physical in the mind. And then we remember that the real Betelgeuse is far away. Because if we leave the comparison too long, it becomes fantasy. The real terror is subtler. Betelgeuse is not in our solar system. It will not replace the Sun. It will not engulf Earth. It is distant, and that distance protects us. But the star is real, and its size is real. Somewhere in Orion, a star exists whose scale would ruin the map of our inner worlds if placed here. The comparison is imaginary. The scale is not. That is what makes the thought so powerful. Betelgeuse also reminds us that stars have outer lives, not only cores. People often think of a star's fate as something happening deep inside, and that is true for the final collapse. But the outer layers matter too. Before the end, the star can lose enormous amounts of material into space. It can surround itself with gas and dust. It can create an environment shaped by its own instability. The star is not only waiting to explode, it is already changing the space around it. This means the future supernova will not happen in a clean, empty room. It will happen inside material the star has already shed. That material may shape what astronomers see when the explosion finally comes. The light will move through the star's surroundings. The expanding blast will interact with gas lost before the final collapse. The death of Betelgeuse will include not only the core's final failure, but the long history of instability that came before it. The swollen giant is already writing the conditions of its own ending. This makes the star feel less like a sudden event and more like a process. The supernova is the climax. The red supergiant is the long approach. That approach is what we are seeing now. When we look at Betelgeuse, we are not watching the final explosion, but we are watching a star in the kind of state that leads to one. That distinction is important. It keeps the story truthful. Betelgeuse is not guaranteed to explode tonight, but it is genuinely in a late phase that makes a future explosion the expected end. Its huge size is not decoration. It is part of the path. A star does not become a red supergiant by accident. It becomes one because its interior life has changed. The swelling is the sky-visible sign of that change. For the viewer, this helps transform Betelgeuse from a scary headline into a coherent story. The headline says, "It could explode." The science says it is a massive star late in life, expanded into a red supergiant, unstable, variable, and headed toward core collapse at some uncertain time. The emotional story says that one of the most familiar red stars in the night is actually a huge dying body, so large that it makes our planetary distances feel small. That is why the chapter has to end with size. Before we talk about its strange dimming, we need to understand that dimming belonged to a star already monstrous in scale. A small change in brightness from a point in the sky can sound minor. But if that point is a red supergiant with outer layers spanning a vast region, then a change in brightness becomes a clue from an enormous, unstable body. It is not like a lamp flickering. It is like a giant star revealing that part of its outer life has shifted. The size makes every change feel more serious. The star is too large to behave like a neat object, too unstable to feel permanent, too far away to show us it's present, and too close, by cosmic standards, to ignore. So when you next imagine Betelgeuse, do not imagine a small red point first. Imagine the red point only as the signal your eyes receive after distance has done its work. Behind it is a swollen giant, a star whose body would overflow the safe inner structure of our solar system, if placed at the center of it. A star whose outer layers are loose, turbulent, and already part of the long road toward its eventual death. The point is small. The star is not. And once that scale is in mind, the famous dimming of Betelgeuse becomes far more unsettling, because when a monster that large suddenly fades, the whole world starts to wonder whether the final act has begun. For most of human history, the stars seemed almost permanent. They rose with the seasons, moved with the night, and returned again the next year with a kind of calm reliability that made the sky feel older than change. People saw planets wander, comets appear, meteors burn, and the moon shift through phases. But the stars themselves seemed like the fixed background. They were the ancient lights, the points that stayed, the patterns that allowed humans to build calendars, myths, navigation, and memory. Betelgeuse had always been one of those familiar lights, not fixed in the deepest scientific sense, but familiar enough that most people could imagine it as part of Orion's identity. A reddish shoulder, a bright marker, a star that belonged where it was. Even if it naturally varied in brightness, as Betelgeuse does, those changes usually remained inside a range that did not make the whole world look up and wonder whether a supernova had begun. The answer, as far as scientists could tell, was no. But for a time, the uncertainty was powerful, because the idea fit too perfectly. Betelgeuse was already known as a massive star near the end of its life. It was already famous as a future supernova. It was already visible to ordinary people without a telescope. And now, suddenly, it was doing something dramatic enough to make headlines. The star that may one day die in front of the entire planet had begun to change in a way people could actually see. That is why the dimming mattered emotionally. It made stellar death feel less abstract. Before the dimming, Betelgeuse's future supernova could be placed safely into the category of someday. Someday this star will explode. Someday Orion will change. Someday Earth may see one of the most spectacular events in the history of the night sky. Someday is easy to hold at a distance. It does not interrupt life. It allows the imagination to visit danger without believing it has arrived. But the dimming pulled someday closer. The better explanation became dust. More precisely, the dimming appears to have involved material ejected from the star, cooling and forming a cloud that blocked some of Betelgeuse's light from our view. The star did not simply run out of light. It was partly veiled. A piece of the star's own outer life had moved outward, cooled, and created something like a shadow between Betelgeuse and Earth. The effect was dramatic enough to make the red giant look much fainter than usual. This explanation sounds calmer than supernova. But it is still not calm. A star had thrown part of itself into space. That is the part people should not miss. The dimming was not the final explosion, but it was still a sign of a star in an unstable late phase. Betelgeuse did not fade because it was boring. It faded because its outer layers are enormous, turbulent, and capable of releasing material into the space around it. The dust explanation does not remove the drama. It changes the drama from sudden death to visible instability. There is a difference. The great dimming became one of the clearest reminders that Betelgeuse is not a smooth red lamp in the sky. It is an active, changing supergiant with a restless surface and extended atmosphere. Its outer layers are not held tightly the way the sun's visible surface seems to be by comparison. They can move, swell, shed, cool, and form material that changes what we see from Earth. The star is not a perfect circle of stable light. It is a massive, uneven, living process in the stellar sense. That may be the deepest cultural effect of the dimming. It reminded people that the stars are not decorations pasted onto the night. They are bodies in evolution. Even the familiar ones are changing. Most changes are too slow, too subtle, too distant, or too technical for ordinary life to notice. But Betelgeuse gave the public a rare feeling that the ancient sky was doing something. Not in myth. A star had faded, and the world had watched. That alone is powerful. Human beings live for such short times compared with stars that we rarely get to feel stellar change directly. We can learn it through diagrams and equations. We can understand that stars are born, age, swell, collapse, and die. But understanding a process intellectually is not the same as seeing one of the brightest stars in Orion become visibly strange. The great dimming made stellar evolution feel present. It made the future of Betelgeuse feel active. Of course, the star brightened again. The sky did not end. Orion remained. Betelgeuse did not become a supernova. The most dramatic public fear passed, and the scientific story became more precise. But the episode left behind a new, emotional memory. Betelgeuse had shown it could surprise us. It had shown that the red point on Orion's shoulder is not reliable in the simple way the human eye once imagined. It had shown that the star can change enough for the whole planet to notice. The world would not need convincing. The sky would do the announcing. This is why the dust explanation can feel more haunting than disappointing. If the dimming had been ignored as not the supernova, we would miss what it revealed. It showed us a star capable of ejecting material from its surface in a massive event. It showed us a star whose brightness can be shaped by its own lost matter. It showed us that the red supergiant is not simply waiting quietly for the end, but living through a turbulent final chapter. A star near death does not need to explode to reveal itself. Sometimes it only has to fade. The public fear was wrong in timing, not wrong in understanding that the star is unstable. That distinction matters for the video. We should not treat the great dimming as proof that Betelgeuse is about to explode tonight. That would be misleading. But we also should not treat it as nothing. It was a rare, visible reminder that the star is active and complex. It pulled Betelgeuse out of the background and made it feel alive in the sky. It turned a future supernova into a present question. Why did it throw material outward? Could another dimming happen? That is the right emotional place for this chapter. Not panic, attention. The great dimming should not make us think the supernova is guaranteed tomorrow. It should make us understand that Betelgeuse is not a quiet, ordinary star. It is a red supergiant, close enough and bright enough for its late-life behavior to become part of human experience. It can change in ways we notice. It can surprise observers. It can send clues through light that take centuries to arrive and still feel new when they reach us. That is a strange relationship. We are watching a star's past behavior become our present mystery. The star's past entered our news. That may sound poetic, but it is literal. The universe does not give us most events as they happen where they happen. It gives us traveling evidence. Betelgeuse's dimming was evidence delivered late. If the supernova ever comes, it will also be evidence delivered late. The great dimming therefore prepared us for the deeper strangeness of the star's future. Whatever we see from Betelgeuse, we see after the distance has had its say. This is why the dimming belongs so naturally before the question of explosion. It teaches caution, and it teaches awe. Caution, because a dramatic change does not always mean the final event has begun. Because even a non-final change can involve an enormous star throwing material into space and altering the light that reaches an entire planet. The universe does not need to end a star in order to show its power. Sometimes a single episode in a star's outer atmosphere is enough to remind us that the quiet sky is full of violent processes. Betelgeuse is peaceful only to the unaided eye. To astronomy, it is restless. That restlessness is what made the great dimming so memorable. It was not only the amount of fading, but the star it happened to. If a less famous variable star changed brightness, the emotional effect would be smaller. Betelgeuse is different because it already carries the weight of an expected future supernova. Every unusual behavior is interpreted under that shadow. Every change feels like a possible clue. Every dimming or brightening invites the question people cannot stop asking. Is this it? The answer, so far, has been no. But one day, the answer will be yes. That sentence is the reason Betelgeuse remains terrifying, even after the great dimming was explained. The false alarm did not remove the real fate. It only reminded us that we do not know how many false alarms, strange episodes, dust clouds, pulses, or surface events may come before the true end. A star can approach death through many restless signs without giving us a clear countdown. There may be no warning we can understand. Or there may be warnings that only make sense after the explosion. That is an unsettling thought for astronomers and for anyone looking up at Orion. The final days of a massive star may not announce themselves in a way humans can decode from far away. Betelgeuse may change, dim, pulse, or shed material again, and we may not know whether those changes are ordinary late-stage behavior or part of something closer to the end. We can model, observe, and learn, but the core remains hidden. The core is where the true clock lives. The surface gives signs, the atmosphere gives clues, the brightness gives hints. But the final collapse begins deep inside, beyond direct sight. That is why the great dimming could be dramatic without being final. The outer star changed, but the core did not yet reveal the end. The supernova depends on the core reaching the last failure. Until then, Betelgeuse can look frightening without exploding. This separation between surface and core is important. A star can appear strange on the outside, while the final internal moment is still not here. The surface is huge and visible. The core is hidden and decisive. Betelgeuse's outer layers can darken, shed material, or change shape, but the supernova waits on deeper physics. This means the visible drama may not tell us exactly how close the final collapse is. That makes the star harder to read and more haunting. We are watching the skin of a giant and trying to guess the fate of its heart. That is what the great dimming really gave us, a glimpse of the skin. Not in the simple human sense, because a red supergiant does not have skin, but as an outer expression of internal and atmospheric violence. A region of the star became obscured. Material left. Dust formed. Light changed. Earth noticed. It was a surface story, but a powerful one. The heart remained hidden. That hidden heart is why the star can return to apparent calm after frightening us. Betelgeuse brightens. Orion looks familiar again, and ordinary nights continue. But the calm is only what arrives at our eyes. It does not mean the star is safe in any lasting sense. It means the final event has not arrived in our sky. Betelgeuse remains what it was before the dimming. A massive red supergiant near the end of its life, uncertain in timing, certain in destiny. The great dimming did not change that destiny. It changed our attention. And attention changes the sky. Once people know a star can behave strangely, they no longer look at it in the same way. Betelgeuse may return to its usual brightness, but the memory of its fading remains. The red shoulder of Orion now carries a modern story alongside the ancient ones. It is no longer only a star that may explode someday. It is a star that once dimmed so dramatically that the world wondered if someday had arrived. That memory will stay with it until the real event comes. Maybe the supernova will happen long after everyone alive today is gone. Maybe it will happen tomorrow night from Earth's perspective. Maybe it already happened centuries ago, and the light is still crossing the dark. The great dimming does not tell us which future is true. It only tells us that Betelgeuse is active enough to keep us watching. And that may be the most honest conclusion. We are not waiting for a guaranteed explosion tonight. We are watching a star whose final explosion is real, whose timing is hidden, and whose recent behavior has already shown that it can surprise us. The fear is not that every dimming is the end. The fear is that one day, some change in that red point will not be a false alarm. One day, the sky will not return to normal. One day, Orion's shoulder may brighten instead of fade. And once we understand why the great dimming frightened the world without being the final explosion, the next question becomes, what would actually happen if Betelgeuse did explode? The first thing to understand is that it would not feel like an explosion in the ordinary human sense. There would be no sound crossing space, no blast wave rushing through the solar system, no sudden wind from Orion striking Earth, no fire in the sky moving toward us like something from a disaster film. Space is too empty for that kind of violence to travel here, in the way human imagination expects. Betelgeuse is far away, and that distance changes the event completely. The star could destroy itself in one of the most powerful explosions in the galaxy. And on Earth, the first sign would be light. Only light. At first, perhaps, it would be noticed by instruments before most people understood what had happened. Astronomers would see a sudden change from the direction of Orion. Automated surveys, telescopes, alerts, and sky monitoring systems might recognize that Betelgeuse was no longer behaving like a normal red supergiant. Its brightness would rise. The familiar red point would begin to transform into something much more intense, much more unnatural, much harder to ignore. The shape of the hunter would be broken by light. That may be one of the strangest parts. We are used to constellations as stable patterns, even though they are only temporary from a cosmic perspective. Orion feels ancient because it has been part of human sky culture for thousands of years. The belt, the shoulders, the legs, the sword, the surrounding stars, together they form something the human mind recognizes almost instantly. If Betelgeuse exploded, the pattern would not vanish, but it would stop feeling balanced and familiar. One red shoulder would become a blazing marker of stellar death. People would look up and understand that something irreversible had happened, not because they could see the star tearing itself apart in detail, but because the sky would no longer look like it did before. A supernova from Betelgeuse would unfold over time. It would not be a single flash lasting only a moment. The light would rise, peak, and then fade across days, weeks, and possibly months, depending on the details of the explosion and how its light traveled through the material around the star. To ordinary observers, this would be one of the most haunting parts. The event would not simply appear and disappear. It would stay. It would become part of the sky for a while, like a temporary new truth written above Earth. For a time, the night would have a new center of attention. There would be awe, fear, confusion, excitement, and perhaps sadness. Some people would feel lucky to be alive for it. Some would feel frightened even after being told Earth is safe. Some would turn it into myth, religion, conspiracy, or prophecy. Some would simply stare, quiet, and unable to fit what they are seeing into the ordinary scale of daily life. The same sky that holds weather, sunsets, aircraft, satellites, and the moon would suddenly hold visible evidence that a massive star had died. That would not be easy to absorb. The death of Betelgeuse would remind people that the stars are not eternal decorations. They are physical bodies with beginnings and endings. From a scientific perspective, the first moments would be a treasure. A nearby red supergiant supernova would be one of the most studied astronomical events in human history. Telescopes would collect light in every possible form: visible light, infrared, ultraviolet, X-rays, radio waves, and more, depending on what the explosion produced and how the material around the star shaped the signal. Neutrino detectors might register a burst from the collapsing core before or around the visible brightening, offering a direct clue from the heart of the dying star. That part is almost impossible to imagine. It might be particles. Then, light would follow. Not in the sense that we could travel there or see inside it directly, but in the sense that the explosion would reveal what the star had become. Elements formed in its interior would be thrown outward. Layers built across its life would be scattered into space. The star's hidden structure would become part of an expanding remnant. The supernova would be an ending, but also a disclosure. It would tell the truth of the star in a way ordinary light never could. That is why astronomers would be desperate to observe everything. The brightness that ordinary people see would be only the surface of the event. Behind it would be a rare chance to watch a massive star die, close enough for detailed study. Betelgeuse is not close in human travel terms. but it is close in astronomical terms for such a famous red supergiant. A supernova there would be a scientific gift of almost unimaginable value. It would allow scientists to test models of massive star evolution, red supergiant mass loss, core collapse, shock breakout, and the birth of whatever compact remnant remains. The event would become history the moment it began. That is a beautiful thought, because the event itself would be the death of a star, but the response on Earth could be a moment of shared attention. People who disagree on almost everything might step outside and point toward the same place in the sky. The supernova would not erase human conflict, but for a brief time, it could create a common reference point, a reminder that everyone lives under one sky, receiving ancient light from the same universe. Still, the sight would be unsettling. A star death visible to the naked eye is not an ordinary event for modern civilization. Most people alive today have never seen anything like it. Historical supernovae were recorded in earlier centuries, and remnants like the Crab Nebula still carry their aftermath. But a bright nearby supernova in the familiar shape of Orion would feel personal in a way distant astronomical images do not. It would not be a picture from a telescope. It would be a change in the real sky. That difference matters. This is often how cosmic reality enters human life. It does not stop all ordinary things. People still eat, sleep, work, worry, love, argue, and age. But above them, a star that once marked Orion's shoulder would be shining with the light of its own destruction. That parallel would be haunting, the ordinary and the cosmic occurring at the same time. A person could look up between errands and see the death of a giant star, but it would not return to the old sky. Betelgeuse as we knew it would be gone. The familiar red supergiant would no longer exist in that form. The constellation would still contain stars, but one of its great markers would have been transformed. The shoulder that helped define Orion for human history would become something else, a fading remnant, a region of expanding gas, the aftermath of a stellar death. Future generations might grow up with a different Orion than the one we inherited. That thought is quietly devastating. Constellations feel ancient because we live briefly. We forget that they are temporary arrangements of moving, evolving stars. Betelgeuse's supernova would make that truth visible in a single human lifetime. The sky pattern that seemed inherited from forever would change. Not because the stars moved in a way we could notice, but because one of them died. The night sky would lose a familiar face. But for Earth, it appeared then. The actual explosion would have taken place hundreds of years earlier because of the distance. That means the supernova would force people to confront cosmic time in a way few events can. The world might treat the brightening as happening now, because for us, it would be new. But every serious explanation would have to say that the event itself was ancient by the time we saw it. Betelgeuse would have died long before Earth knew. This is what makes the scenario so contemplative. The sky would become a delayed message. A giant star's final act would cross space for centuries, unnoticed by us until the light arrived. During that travel time, generations on Earth would live and die under an Orion that still looked normal. Empires, technologies, families, wars, discoveries, and lives would pass beneath a sky carrying a hidden future in transit. The information would be coming the whole time, but nobody would know until it reached us. The supernova would feel sudden only because the universe had kept the news far away. That is not just poetic. It is physics. That double meaning is part of the terror. Tonight for us is not tonight for Betelgeuse. There is no single shared now between Earth and a star hundreds of light years away in the everyday sense. Relativity and light travel time separate observation from event. The supernova would teach that lesson not as an abstract idea, but as a visible wound in a familiar constellation. The sky would show us that the universe is made not only of distance, but of delayed awareness. That may be more frightening than the explosion itself, because the explosion would be safe. The delay changes how we understand reality. We would be watching an old death become new. A catastrophe from the past would enter the present. A star that may already have changed would still appear normal until its final light reached us. Betelgeuse would remind humanity that much of what we call the universe tonight is actually the universe as it was. The farther we look, the older the truth becomes. But during the event, that philosophical idea would be mixed with a simple visual shock. A new brightness near Orion. People would ask how bright it will get, how long it will last, whether it can be seen during the day, whether it is dangerous, whether animals will react, whether ancient people saw similar events, whether this changes astrology, whether it means anything for Earth. Some questions would be scientific, some would be emotional, some would be confused. That is what happens when a cosmic event enters public life. The sky does not arrive with footnotes. It arrives as experience. Then science explains. Slowly, carefully, repeatedly. Astronomers would tell the world that the light is from a supernova, that Betelgeuse was far enough away to be safe, that the brightness is the star's energy arriving after a long journey, that the explosion itself happened long ago, and that what we are seeing is one of the great natural endings of massive stars. They would explain that Earth is not being destroyed. They would explain what telescopes are measuring. They would explain why this event matters. The explanations would help, but the awe would remain. Because no explanation can make the sight ordinary. Understanding does not shrink Betelgeuse. It deepens it. Knowing that the light is old, that the star was massive, that the explosion was safe, that the remnant will expand, and that the elements may enrich surrounding space only makes the event more profound. Science does not remove the terror. It gives the terror shape. That is the ideal feeling of this chapter. Not panic, not fantasy. With structure. If Betelgeuse exploded, Earth would not experience the star as a nearby disaster. We would experience it as a cosmic revelation. The event would show how stars die, how light travels, how distance protects, how time delays truth, and how the familiar sky can change. It would turn a point in Orion into a lesson visible to millions or billions of people. For a while, the whole planet would live beneath an altered constellation. Then, slowly, the light would fade. The supernova would become a remnant. The headlines would fade too. People would return to normal life, but the memory would stay. Astronomy would never be quite the same for those who saw it. Orion would never be only the old hunter again. It would become the constellation where humanity watched a giant star die. And perhaps the most haunting part is that nothing about Earth would need to move. The whole event would happen with us standing still. No spacecraft required. No telescope required for the basic sight. No journey beyond the atmosphere. A star, hundreds of light years away, would change, and the evidence would simply arrive. It would enter our sky, our eyes, our cameras, our instruments, and our history. We would be witnesses because light finally reached us. That is what would actually happen. A silent arrival of ancient violence. A red star becoming a brilliant death. A familiar constellation changing shape in human memory. And after imagining that first impossible light in the sky, the next thing to understand is why Earth would survive it. That may sound strange after everything we have said about Betelgeuse. A massive star dies. Its core collapses. Its outer layers are blasted into space. Light pours outward with a power almost impossible to compare with anything in human experience. For a time, one star can shine with the brightness of an entire galaxy of ordinary stars. The event is violent enough to tear a supergiant apart and scatter its material into the surrounding darkness. And yet Earth would survive. not because Betelgeuse is weak, too far to end the world. This is why the fear around Betelgeuse has to be shaped carefully. The title says terrifying, and it is terrifying, but not because the star is about to burn Earth. The terror is not a wall of fire racing towards us. It is not the oceans boiling under Orion. It is not a shockwave ripping through the solar system. Those images belong to the wrong scale. They are human disaster images pasted onto an interstellar event. The real terror is colder and deeper. That would be human. A star dying in the sky would reach something older than modern science inside us. Even if the event caused no harm, it would look meaningful. It would feel like a warning, a sign, a rupture in the normal order of night. Human cultures have always responded powerfully to sudden changes in the heavens. A supernova in Orion would be explained by physics, but it would still be felt by people living under it. Safety does not remove awe, and awe is not always comfortable. The safe distance of Betelgeuse also teaches something important about scale. Hundreds of light years is close for astronomy, but impossibly far for human life. We call Betelgeuse nearby because the galaxy is so large, not because it is nearby in any human sense. The word nearby changes meaning when the subject is a star. A nearby star can still be so distant that its explosion becomes a light show rather than a catastrophe. That difference can be hard to feel. Not to us. This does not make the event gentle. Betelgeuse's supernova would be catastrophic for Betelgeuse. The star, as we know it, would cease to exist. Its outer layers would be thrown outward at enormous speeds. Its inner core would collapse into something far denser and stranger than the star it once supported, perhaps leaving behind a neutron star or possibly another compact remnant, depending on the details. A giant that glowed for millions of years would end in a transformation lasting moments at the core and unfolding visibly across time as the light arrived. They changed the meaning of life for a while. An eclipse does not harm the planet, but it can silence crowds. A meteor shower does not threaten civilization, but it can make people gather under dark skies. A comet passing near Earth may be harmless, but it can live in memory for decades. Betelgeuse becoming a supernova would be like that, but far greater. It would be safe enough to watch and powerful enough to change the emotional texture of the sky. The fear would become philosophical. Not will we survive, but what are we looking at? That is the deeper discomfort. If Betelgeuse can die so violently while appearing as a calm red point for centuries, then what else is hidden inside the stillness of the sky? Every star becomes less like a decorative light and more like a physical process with a beginning, a middle, and an end. The night becomes a field of stories at different stages. Some stars are young, some are stable, some are already dying. Some may already be gone, with their light still on the way. Betelgeuse would make that reality visible. A dangerous event may produce panic and then relief. A safe but enormous event can change how a person sees the universe. Betelgeuse exploding would not chase us into shelters. It would invite us outside. That is the strange inversion. The death of a star would make people step into the night, not hide from it. The safest response would be to look up. Looking up would become the human act. Earth survives because it is far away, but Earth witnesses because it is not infinitely far. We are in the right zone for awe. Close enough for Betelgeuse to be bright and famous, far enough to be safe. That is a rare emotional position. The star is not so distant that its death would be invisible to ordinary people, and not so close that the event becomes a biological crisis. It sits in the strange middle where cosmic violence becomes sky memory. A safe supernova is still a supernova. The word safe should not make it feel soft. It only describes the effect on us. At the star, the event would be beyond anything soft. The outer layers would be torn away. The star's previous form would end. Material built across its life would be hurled outward. A shock would move through the star and its surroundings. Light would pour into space. The core would become something new and extreme. Safe from Earth does not mean gentle in Orion. For Betelgeuse, it would arrive as brilliance. This brilliance could affect the night in ways people would remember intensely. Depending on the exact brightness and timing, it might appear during twilight, shine through light pollution, and change the feeling of Orion for weeks or months. It could become an object that people check night after night, watching it evolve. The fading would be part of the experience. At first, shock, then familiarity, then slow loss as the light declined. A safe sky can still feel haunted. Imagine seeing Betelgeuse bright enough that Orion no longer looks like Orion. Imagine knowing that the star whose light is reaching you no longer exists in its former body. Imagine explaining to someone that Earth is fine, that there is no danger, that the supernova is far away, and then looking up together and feeling how strange safety can be when the sky itself has changed. Not terror of death, terror of understanding. Understanding that the universe contains explosions so powerful they can rewrite the night without touching us. Understanding that distance can protect us while still delivering the evidence of destruction. Understanding that the stars have private lives and deaths that become public to us only when their light arrives. Betelgeuse belongs to that category. The safe distance also helps explain why scientists are so eager for the event, even if they do not expect it soon. A supernova close enough to threaten Earth would be a nightmare. A supernova too far away would be scientifically useful, but less visible to the public. Betelgeuse sits in a remarkable place, a famous nearby red supergiant whose death could be studied in great detail while remaining harmless to us. It is the kind of event astronomers would dream of observing, not because they want the star to die, but because the death of such a star would teach us something we cannot learn any other way. A safe catastrophe can become knowledge. That phrase sounds contradictory, but it is exactly what astronomy often gives us. We cannot touch the event. We cannot stop it. We cannot cause it. We cannot save the star. But we can receive the light, measure it, study it, and understand more about how massive stars end. Earth survives, and because it survives, it can learn. That is the gentle side of the fear. The star dies, the observers live. The knowledge remains. This is different from human-scale disaster, where survival often comes with grief, damage, and rebuilding. With Betelgeuse, the grief would be abstract, if grief is even the right word. We might feel the loss of a familiar star in Orion, but no city would be destroyed by it. No ocean would rise because of it. No forest would burn from the supernova light. The event would belong to the sky, not to human infrastructure. And yet, the emotional loss could be real. People can mourn changes in the sky, not like mourning a person, but as a loss of familiarity. Orion has looked a certain way for all of human history. Betelgeuse's red glow is part of that inherited sky. If it exploded and faded, future Orion would be different. A safe event can still remove something ancient from human experience. Earth survives, but the old Orion does not. This is an important balance. The chapter should not reassure so much that all wonder disappears. It should not say, "Do not worry, nothing matters." Instead, it should say, "Earth is safe," and that safety allows the full wonder of the event to be felt. We would not be watching our own end, we would be watching a star's end. That difference is everything. It lets the mind open. If Betelgeuse explodes, humanity would not be a victim. Humanity would be a witness. Witnessing is powerful. To witness is to stand at the edge of an event and carry it into memory. The event itself happens elsewhere, but the meaning enters you. A supernova from Betelgeuse would happen in Orion, but the memory would happen on Earth. It would become part of human history because humans would see it, record it, explain it, tell stories about it, and pass the memory forward. That is why survival matters so much. Without survival, there is no witness. With survival, there is awe. The fact that Earth would survive Betelgeuse is not a footnote. It is the condition that makes the whole story possible as a human story. We can imagine the light. We can imagine people gathering under it. We can imagine scientists learning from it. We can imagine the old sky changing and the world continuing. We can imagine the strange peace of being safe under a visible stellar death. This is where the terror becomes almost beautiful. A dangerous star far enough away becomes a teacher. A dying giant becomes a temporary lantern. A catastrophic collapse becomes a lesson in distance. The sky becomes both safe and changed. And people, standing under that sky, may feel something that has no easy name. Gratitude for distance, sadness for the star, awe at the brightness, and fear at the scale. All of those feelings can exist together. That is why Betelgeuse is such a strong subject. It does not give only one emotion. It gives many at once. It is familiar and alien, safe and terrifying, beautiful and violent, present in the sky and ancient in time, close enough to matter and far enough to spare us. The supernova would not be a Hollywood disaster. It would be a cosmic reminder that our safety does not make the universe gentle, and the universe's violence does not always make us unsafe. The distance decides. And in this case, the distance is merciful. But mercy is only how it feels to us. In reality, it is geometry. Betelgeuse sits far enough away that the energy spreading from its death would arrive diluted, transformed into spectacle rather than destruction. The same laws that make stars enormous also make space enormous. The same universe that produces the explosion also provides the separation that protects us. That is a strangely calming thought. The universe contains danger, but also distance. It contains death, but also delay. It contains violence, but also perspective. Betelgeuse's supernova would bring all of that into one visible event. People would look up and see the evidence of a star's end, while standing safely on a world that continues to turn. The contrast would be almost impossible to absorb. A massive star dies, a small planet survives, the light travels, the sky changes, life continues. That is the true shape of the scenario. Not apocalypse, not nothing. A safe, cosmic shock. And after understanding why Earth would survive the explosion, the next haunting truth is that the light itself would be ancient. This is the part of Betelgeuse that makes the mind slow down. If the star exploded and the sky changed tonight, it would feel like something was happening now. People would step outside now. Cameras would point upward now. News would spread now. Scientists would begin explaining now. The brightening would enter human history as a present event, something that arrived in our lives, in our century, in our night sky. But the star itself would not be dying now, not from its own point of view. Astronomy teaches that this instinct is wrong. The sky is not a live picture. It is a memory arriving at the speed of light. For Earth, Betelgeuse could appear to explode tonight. For Betelgeuse, if the star physically exploded tonight, Earth would not know for centuries. Those are two different meanings of the same sentence, and both are true in their own frame. That is why the title feels so haunting. It does not only suggest an unpredictable star, it suggests a universe where now is not shared across distance. What happens there and what is seen here are separated by a long river of light. The river may already be carrying the answer. If Betelgeuse has already exploded, the evidence is somewhere between there and here, moving through space at the fastest speed anything can travel. It may be halfway across the distance, It may be almost here. It may not exist yet because the star has not exploded. We have no way to step outside the light and check. We can only receive what arrives. That is the helplessness of observation. Betelgeuse teaches this in a way people can feel. A famous star in a familiar constellation may already be different from what it seems. Then, centuries pass. The light continues. Civilizations change. Languages shift. This is what makes the scenario feel so dreamlike. The supernova would not only be a sky event, it would be an event whose announcement traveled through human history without anyone knowing it. The news would move through space, while Earth carried on with wars, discoveries, love stories, inventions, migrations, nights of sleep, and ordinary mornings. The universe would be holding a secret in transit. Then, one night, the secret arrives. That is why Betelgeuse's future supernova would be a lesson in time as much as a lesson in stars. It would show that the universe is not arranged around human immediacy. Events do not become real when we learn about them. They happen in their own places, under their own conditions, and only later enter our knowledge. Betelgeuse may change whether or not we are ready. The light will arrive when the distance allows, not when the human mind wants certainty, the mystery of a real object whose present is inaccessible. In daily life, hidden things can sometimes be reached. A closed door can be opened. A message can be sent. A person can travel to another city. A camera can show a distant place. But Betelgeuse is hidden by light years. We cannot simply look harder and see it now. We can only see the photons that have arrived. The ones carrying its current state, whatever that state is, are still on the way if they exist at all. This is why looking at Betelgeuse is almost like listening to an echo. The star speaks in light, and the echo reaches us late. A death report. The distinction matters. A warning comes before danger. A report comes after the event. Betelgeuse's supernova light would not warn us that the star is about to explode. It would tell us that it already did. By the time we see it, the star's former body would already be gone. The remnant would already be expanding. The core would already have collapsed. The old red supergiant would already belong to history. Light travel time would stop being an abstract concept. It would become visible. It is many moments arriving together. This is true every night. The moon, planets, stars, nebulae, and galaxies all arrive from different delays. The night sky is a mixture of times, blended into one visual experience. But because most of those lights remain stable from night to night, the mixture feels like a single present. Betelgeuse exploding would tear that illusion open. One point would change so dramatically that the age of its light could not be ignored. That is another reason Betelgeuse matters. Its supernova would not only be physics, it would enter human memory. It would become a date, a story, a before and after sky. People would say they saw the ancient light arrive. They would describe where they were, how bright it looked, how strange Orion became, and how it felt to know that the death had happened long before. The delay would become part of the memory. The event would be old, the memory would be new. This contrast is almost tender. The star's death might have occurred before the lives of everyone who sees it. Yet those people would carry the experience as something personally witnessed. They would not have witnessed the event at the source. They would have witnessed its arrival. That is enough for human memory, because we live where we receive the light. Our world is shaped by what reaches us. Earth's version of the supernova is the arrival. Betelgeuse's version is the explosion, a sphere of light carrying the fact of a death. When that sphere reaches Earth, our sky changes. Until then, Orion remains old. This is why the idea that Betelgeuse may already be gone feels so powerful. It may not be true. The star may still be there. but the possibility is built into the way light works. There is no contradiction in seeing a star that has already changed, because sight depends on the past. We do not see what is. We see what arrived. Betelgeuse may still exist exactly as the light suggests, or it may not. The universe does not tell us until the light arrives. This uncertainty is different from normal uncertainty. It is not only about imperfect measurement. It is not only because we lack a better telescope or a better model. Even with perfect observation, the present state of Betelgeuse cannot be known faster than light. The limit is not our laziness. It is the structure of space-time. The star's true current condition is causally separated from us until its light reaches Earth. We can estimate, we can model, we can monitor. We can say it is unlikely to explode on any given night. We can say it may not explode for a very long time. But we cannot stand outside the light delay and see the star as it is right now. The universe does not allow that kind of shortcut. This gives Betelgeuse a kind of dignity. It keeps its present to itself. Every night it sends us only an old version, and we build our understanding from that old light. The red star we see may be faithful to the star's current life, or it may be an image waiting to be replaced by news that left long ago. This is why the red point can feel so calm and so haunted at the same time. Calm because it shines as usual. Haunted because the calm may be old. That is the emotional center of the ancient light chapter. The light is real, the image is real. But the time is not what it seems. When Betelgeuse glows above Earth, it is not lying to us. Light does not lie. It carries information honestly from the moment it was emitted. But we may misunderstand it if we forget the journey. The light tells us what was true then, not necessarily what is true now. The error is not in the light. The error is in our instinct to treat seeing as immediacy. Astronomy trains us to separate those things. Seeing is not always knowing the present. Sometimes seeing is receiving the past. Betelgeuse makes that lesson beautiful because it is visible, famous, and emotionally charged. A distant galaxy also shows us the past, but most people cannot look at it easily without instruments. Betelgeuse is different. It is naked eye time delay. It is ancient light visible from a backyard. It is cosmic history placed in a constellation many people can find. That accessibility matters. The deepest ideas in astronomy become stronger when they are attached to something visible. You can tell someone that light takes time to travel, and they may understand it intellectually. But if you point to Betelgeuse and say, that red light began its journey centuries ago, the idea becomes personal. If you add that the star may one day explode, and we will only know when the old light reaches us, the idea becomes haunting. A point in Orion becomes a lesson in time. The ancient light also changes how we think about the future. Normally, the future is something ahead of us. But with Betelgeuse, the future of our sky might already be traveling toward us from the past. If the supernova has already happened, then Earth's future observation is fixed in a beam of light already crossing the space between stars. The future is not always unwritten in the way it feels from here. Sometimes what will happen to our sky has already happened elsewhere. That thought is unsettling, but also strangely calming. It means the universe is larger than human suspense. Our not knowing does not mean the event is undecided. It means the information has not arrived. This is true in many parts of life, but space makes it pure. On Earth, hidden information can often be searched for, uncovered, leaked, measured, or revealed through effort. Across light years, effort has limits. You cannot run faster than the signal. You cannot force tomorrow's photons to arrive today. You cannot interrogate a star's current state across hundreds of light years. You must wait. Betelgeuse teaches waiting at cosmic scale, and that waiting is not empty. It is filled with observation. Astronomers continue watching the star. They track its brightness, its surface behavior, its atmosphere, its dust, its variability, and its strange moods. Every new measurement is valuable, but every measurement is still delayed. We are building a history of Betelgeuse from light that has already traveled through time. The star's biography reaches us in pieces. Some pieces are calm, some are strange. One piece, someday, will be final. That final piece will not come with a warning label. It will simply arrive as light. And the instruments will notice. The sky will change. The world will react. Then the explanation will follow. The star died long ago, and we are only now seeing it. The most dramatic moment will also be the clearest lesson. The universe is not only far away, it is late. Late, from our point of view. The light from Betelgeuse is always late. And if the supernova light arrives, it will be the most important lateness in the modern sky. This is why the ancient light chapter belongs before the human reaction. Before imagining people gathering outside, before imagining photographs, headlines, and children remembering the changed sky, we have to understand what they would actually be witnessing. They would not be witnessing the death itself in the star's present. They would be witnessing the arrival of the death's evidence. That distinction makes the human reaction deeper. People would not only see brightness, they would see time. They would see the past enter the present so brightly that it could cast shadows. They would see a message that crossed centuries without sound. They would see proof that the calm red point in Orion had been only a delayed image all along. The night sky would become historical in a way no one could ignore. That is why Betelgeuse is more than a future supernova. It is a reminder that every star is a messenger from its own past. Some messages are recent by cosmic standards. Some are ancient beyond human history. Some may come from stars that no longer exist. Betelgeuse sits in the unsettling middle, close enough to feel near, distant enough to be old, unstable enough that the age of its light matters emotionally. The red star may be alive. The red star may already be gone. The only thing we know is what its old light tells us. And as that ancient light continues to arrive from Orion, the next thing to imagine is the day the whole world looks up and realizes the night sky has changed. It would not begin the same way for everyone. For some people, the first sign might be a notification on a phone, a headline appearing between ordinary messages, a short alert saying that astronomers have detected a dramatic brightening in Betelgeuse. For others, it might be a photograph sent by a friend, a post from an observatory, a live stream from someone standing under a clear sky, or a news anchor trying to explain why one of the most famous stars in Orion is suddenly no longer behaving like a star people remember. But for many, the real moment would happen outside. They would step into the night and look toward Orion. The human mind is built to remember changes in the sky. Eclipses, comets, meteor storms, bright conjunctions, auroras, fireballs, and unusual moons all leave impressions because the sky usually feels stable. When something up there changes dramatically, it feels larger than a local event. It feels shared. A storm belongs to one region. An earthquake belongs to one landscape. But a changed constellation belongs to everyone who can see it. Betelgeuse would not be a private phenomenon. It would be a planetary experience. Not everyone would see it the same night. Weather would interfere. Daylight would hide it for some. Orion would be below the horizon for others. Some places would have clouds, city lights, rain, haze, or no view at all. But the knowledge would spread faster than the visibility. People who could not see it yet would wait for their chance. They would check sky maps, weather apps, live feeds, and photographs from clearer places. The event would create a strange kind of global waiting. Millions of people knowing the sky has changed before their own sky allows them to witness it. That waiting would make the moment even more powerful. The old pattern would become a before and after image. Before Betelgeuse exploded, after Betelgeuse exploded. That kind of change gives the sky a history the public can feel. We know intellectually that the sky changes. Stars move slowly, planets wander, the moon cycles, the sun's path shifts with the seasons. But the deep star patterns feel permanent, because their changes are usually too slow for one lifetime. Betelgeuse becoming a supernova would break that illusion. It would show that even the most familiar constellations are temporary arrangements of living and dying stars. The hunter would no longer be ancient in the same way. He would have lost a shoulder. People would tell children about it. That may be one of the strongest images. A child too young to understand nuclear fusion could still understand that the bright thing near Orion was once a star, and that it exploded long before the light reached Earth. Parents would point upward and explain, as simply as they could, that the sky is showing something old and enormous. Some children might feel afraid. Some might feel wonder. Some might remember it for the rest of their lives as the first time the universe felt real. In that sense, Betelgeuse would educate the world simply by changing. The event would also reveal the difference between fear and knowledge. At first, rumors would spread. Some would exaggerate the danger. Some would misunderstand the brightness. Some would claim it was a sign of something supernatural, political, spiritual, or conspiratorial. That is unavoidable when the sky changes. But the scientific explanation would also spread. The more people learned, the more the event could shift from panic into awe. Curiosity is a calmer form of fear. It says, "This is strange, but I want to understand it." A Betelgeuse supernova would create that kind of curiosity on a scale few astronomical events can match. People who normally do not think about stars might ask what a red supergiant is. They might learn why the sun will not explode this way. They might learn why distance protects Earth. They might learn that the light is ancient. They might learn that the atoms in their bodies were also shaped by earlier generations of stars. A star death could make people feel connected to the history of matter. That is the strange beauty of supernovae. They are endings, but they also explain beginnings. The calcium in bones, the iron in blood, the oxygen we breathe, the silicon in rocks, the elements that build planets and life. Much of the heavy material in the universe was forged or spread by stars and stellar explosions across cosmic history. Betelgeuse's death would remind people that the universe is not only distant, it is ancestral. The matter of Earth has its own stellar past. The night sky changing would therefore not only say that a star died, the event would be terrifying, because it is death. It would be beautiful, because it is also transformation. This does not make the event smaller. It makes human life stranger, because ordinary life would continue under a transformed sky. People would still worry about money, health, family, school, work, and the future. Couples would argue under the light of a supernova. Drivers would sit in traffic beneath it. Hospitals would glow through the night while Betelgeuse shone above. Someone would be born while the old star's deathlight reached Earth. Someone would die under it. Life would keep moving through its small human dramas while the galaxy placed a stellar ending overhead. That contrast is one of the deepest emotional pieces. Betelgeuse would be one event with billions of interpretations. That might be chaotic, but it would also be human. The scientific fact would be one thing: a massive red supergiant has undergone a supernova and its light has reached Earth. Around that fact, human meaning would grow in every direction. Songs, images, essays, prayers, jokes, documentaries, classroom lessons, and late-night conversations would follow. People would name the moment. They would compare photographs. They would argue about how bright it was. They would ask whether any ancient observer had ever seen something like this in another star. The supernova would become culture. Betelgeuse already has that potential. The supernova would awaken it completely. People might remember life before the supernova and after the supernova, not because daily life ended, but because the sky changed enough to mark a boundary. In the same way people remember a rare eclipse or comet, Betelgeuse would become a timestamp. A person might say, "That was the year Betelgeuse exploded in our sky." The phrase would become part of human memory, even though the actual explosion happened centuries earlier. Again, the event would belong to two times: the star's time and Earth's time. Earth's time is the time of memory, the time when people see, record, react, and tell stories. Betelgeuse's time is the time of the event itself, long separated from us by distance. The supernova would join those times only when the light arrived. That arrival would become our version of the event, the only version human experience can hold directly. This is why the day the night sky changes would feel almost sacred to many people. The sky would not be background anymore. It would be event. And then, slowly, the event would evolve. The brightness would change. The color might shift. The spectrum would tell scientists about the expanding material. The peak would pass. The supernova would begin to fade. This fading would be emotional too. At first, people might not believe it is fading. Then, it would become obvious. Night after night, Betelgeuse would become less overwhelming. The temporary new center of Orion would soften. The world would watch the light leave. That may be even more haunting than the arrival. A sudden brightening creates shock, but fading creates reflection. It gives people time to understand that the event is not permanent. The star that once lived as Betelgeuse is gone. The supernova light is not a replacement star, only a temporary blaze from the destruction. The sky gives, then withdraws. The event becomes memory while people are still watching it happen. The fading would teach that even cosmic brilliance is temporary. That lesson fits Betelgeuse perfectly. The star itself was temporary. Its supernova would be temporary. The changed sky would be temporary. Even the memory will eventually become history, then perhaps myth, then a line in future astronomy lessons. But for those alive during the event, it would be immediate and unforgettable. Temporary does not mean small. Some temporary things define entire lifetimes. After the fading, Orion would look different again. Maybe the remnant would not be visible to ordinary eyes in the same way. Maybe telescopes would reveal expanding material, a new nebula, a growing structure where the red supergiant once lived. The old Betelgeuse would no longer anchor Orion's shoulder as before. Future generations might learn that the constellation once looked different, and that people long ago watched the change. They might grow up with images of the old Orion and the new Orion, the way we look at maps of coastlines before and after change. The sky itself would have historical versions. That is a profound thought. We often imagine the sky as the thing history happens under. But in this case, the sky would have its own historical, before and after. Human history would not merely record an event in the sky. The sky would become part of history as a changing participant. This would change the emotional relationship people have with Orion. It would no longer be only a winter constellation, a familiar shape, or a story from ancient sky cultures. It would become the place where modern humanity saw a supernova from a famous nearby star. The constellation would carry memory of a real stellar death, not just mythic drama. Orion would become a monument, not built by humans, made by absence and light. The absence matters. Once the supernova fades, what people remember may not only be the brightness, but the missing old star. Betelgeuse, as a red supergiant, would be gone. The shoulder would no longer feel the same. The loss would not be practical, but it would be real in a cultural and emotional sense. A familiar star that helped shape human night would have ended. That is why a safe supernova can still feel like loss. Earth survives, but the old sky does not. And perhaps that is the true human shock. We often think of safety as the end of fear, but some fears remain because they are not about survival. They are about change, impermanence, and the realization that even the things we thought of as permanent are only passing through time. Betelgeuse would show that permanence was always an illusion created by the shortness of our lives. The stars change. We simply do not usually live long enough to see it. A Betelgeuse supernova would give humanity a rare chance to witness that change directly. It would collapse cosmic time into human memory. It would make the death of a star part of ordinary conversation. It would teach children that constellations are not forever. It would remind adults that the sky is not frozen. It would give scientists more data than they could process quickly, and give ordinary people a reason to look up again and again. That is what the day the night sky changes really means. It is not only a bright object appearing, it is the moment a familiar universe becomes unfamiliar. It is the moment Orion stops being only an ancient pattern and becomes a record of stellar death. It is the moment people realize that a star can spend centuries sending calm light and then, one night, send the proof of its own destruction. It is the moment the public understands that the sky carries events, not just scenery. For many, the feeling would be quiet, standing outside, looking up, seeing the changed shoulder of Orion, knowing Earth is safe, knowing the star is gone, knowing the light is ancient, knowing the moment will never happen again in the same way. That is not panic, it is awe with sadness inside it. And as the world slowly learns to live under a changed Orion, the next question becomes, what would be left behind after Betelgeuse is gone? At first, the answer might seem simple. A star explodes, its light fades, and then the star is no longer there. The familiar red point disappears from Orion. The supernova becomes history, and the sky moves on without the shoulder it once carried. From Earth, that may be how the story feels. One star brightens beyond imagination, dominates the night for a while, and then slowly weakens until the old shape of the constellation is gone forever. But a supernova is not only an ending, it is also a release, a growing nebula, a memory made of matter. This is one of the most important things to understand about stellar death. A supernova is not a final punctuation mark. It is a transformation from one kind of object into several others. The star's outer layers become an expanding cloud. The core becomes something dense and extreme if enough of it remains. The surrounding space becomes disturbed by the shock. The light becomes a message traveling across the galaxy, and the material becomes part of a much longer story. The death becomes part of the next beginning. This is why supernova remnants often look beautiful in telescope images. They are not beautiful because the event was gentle. They are beautiful because the violence expands into structure, filaments, shells, knots, glowing gas, shocked material, and layered colors appear as the remnants interact with the space around them. The beauty is the after-image of destruction. It is what happens when a star's death keeps moving. Betelgeuse could leave something like that behind. Not instantly in the fully developed way people imagine from famous nebula images, but over time, the remnant would grow, the material would expand, the glow would change. Telescopes would follow the aftermath for years, decades, centuries, and longer. Future astronomers would not only study the bright supernova, they would study what it became after the first light faded. The death would have an afterlife. This afterlife would be scientific and emotional. Scientifically, the remnant would tell researchers how the explosion unfolded, how much material was ejected, how the shock moved, what elements were present, and how the dying star had shaped its surroundings before the final collapse. Emotionally, the remnant would become the new identity of the place where Betelgeuse once shone. The red star would be gone, But the region of Orion would not be empty. Something new would occupy the memory of the old star. But by turning endings into traces, the most mysterious thing left behind would be the core. In a massive star, the core is where the final collapse begins. When the star can no longer support itself, the center falls inward with unimaginable force. Depending on the mass and details of the collapse, the remnant of that core may become a neutron star, an object so dense that ordinary matter is crushed into a state beyond normal experience. Or, if enough mass collapses further, the final object could become a black hole. For Betelgeuse, the exact remnant is uncertain, but the idea itself is haunting. Outward, an expanding cloud. Inward, a collapsed remnant. One face spreads into space, growing larger with time. The other becomes smaller, denser, and stranger. One becomes a glowing afterimage of the old star. The other becomes the hidden heart of what remains. Together, they would form the new reality of the Betelgeuse system after the red supergiant is gone. This is why saying Betelgeuse would disappear is too simple. From Earth, the most visible consequence would be the fading light and the changed constellation. Through telescopes, however, the region would become richer with time. Astronomers would watch the expanding material. They would map the remnant. They would search for the compact object at the center. They would compare observations with predictions made before the explosion. Betelgeuse would become one of the greatest case studies in the death of a red supergiant. The star would no longer exist as it once did, but it would become even more revealing. The public might move on faster than the science. That is normal. That comparison helps us feel the future. A supernova is not only a night sky event, it can become a 1,000-year object of study. If Betelgeuse exploded, future people might not see the supernova the way the first generation did. They might grow up after the bright phase is gone, learning about it through recordings, images, data, and stories. But they may still see the remnant through telescopes. They may know Orion as the constellation where a famous red star died and left a cloud behind. The event would move from experience into history, then from history into astronomy, then from astronomy into culture. The sky would contain a grave and a birth site at the same time. A grave, because the old star is gone. Betelgeuse's atoms would not all have the same fate. Some would race outward in the expanding debris. Some might form dust. Some might mix with older material already surrounding the star. Some could eventually drift into interstellar space and become part of larger clouds. Some might remain near the remnant. Some may be locked into structures we cannot predict, but none of this requires the star to remain a star. The old identity ends, while the material continues to take part in the galaxy. Identity is temporary. Matter continues. This thought connects Betelgeuse back to us in a quiet way. The atoms in our bodies also have ancient stellar histories. We are not separate from the life and death of stars. Earth formed from material enriched by earlier generations of stellar processes. The iron in blood, the calcium in bones, the oxygen we breathe, the silicon in rocks, the carbon in life. These are part of a long, cosmic inheritance. Betelgeuse, when it dies, would add its own material to that inheritance for future times. We would not be made from Betelgeuse directly, but we are made from the same kind of cosmic story. That does not make it gentle. It does not turn the death of Betelgeuse into something soft or comforting. The violence remains. The star's old form ends. The red supergiant is destroyed. But the meaning becomes larger than destruction alone. The matter is freed. The remnant expands. The galaxy receives new material. Future structures may one day carry pieces of that death forward. This is the calm center of the chapter. Betelgeuse would be gone, but not wasted. The old red point would vanish from Orion, but the star's material would not become nothing. The light would fade, but the remnant would grow. The familiar shoulder would change, but the region would become scientifically richer. A dying star would stop being a single object and become a process spreading through space. That is the afterlife of a massive star. Not memory alone, material, motion, chemistry, a compact remnant, an expanding cloud, a future contribution to the galaxy. The word afterlife can be dangerous if it sounds mystical, so it should be understood physically. Betelgeuse would not continue as a conscious thing. It would not know what it had become. It would not intend to seed the future. Stars do not have purposes, but physics gives them consequences, and those consequences can last far beyond the bright event that begins them. A supernova remnant is consequence made visible. That consequence would grow while humanity changed beneath it. The first generation would remember the bright explosion. Later generations would remember the remnant. Even later, perhaps only scientists and sky lovers would think often about the old red star. But the material would still move. The shock would still expand. The compact core, if visible in some way, would still remain. Betelgeuse's death would become part of a longer galactic circulation. That circulation is much larger than human history. It does not care whether we name it, but naming helps us feel it. We call the star Betelgeuse. We call the pattern Orion. We call the event a supernova. We call the aftermath a remnant. These names are human handles placed on processes far older and larger than us. They do not control the processes, but they let us think about them. They let us return to them in stories, science, and memory. After Betelgeuse is gone, the name may remain. That name would change meaning. Today, Betelgeuse means the red supergiant on Orion's shoulder. After the supernova, Betelgeuse may mean the star that was there, the supernova that changed the sky, the remnant that grew afterward, and the famous example of stellar death, witnessed by modern humanity. The name would become layered. It would no longer point to one stable object. It would point to a transformation. In that sense, Betelgeuse would not be erased from the sky. It would become more historical. A living star is present. A dead famous star becomes memory, science, and trace. That trace may last far longer than the bright supernova. The initial brilliance might dominate for weeks or months, but the remnant could be studied for centuries. In the far future, when the first witnesses are gone, when the original fear has softened into history, what remains in the sky may be less dramatic to the eye, but deeper in meaning. A nebula, a remnant, a record of a death that people once saw arrive. This is how the universe keeps its ruins. Not as stone walls, as expanding gas, as compact cores, as chemical enrichment, as light still traveling outward. Betelgeuse's light would not only reach Earth, it would continue beyond Earth, carrying the information of the explosion farther into space. Other worlds, if any observers exist in the right directions, would see it at different times. The supernova would keep arriving elsewhere long after it entered our history. The star's death would not have a single audience or a single date. It would move through the galaxy as a growing announcement. That is another form of what remains. The event becomes information in motion. Even after Earth has seen it, the light keeps going. This makes the end of Betelgeuse feel less like a point and more like a wave. There is the physical explosion at the star. There is the expanding debris. There is the compact remnant. There is the light moving outward. There is the memory on each world that receives it. The star's death becomes many things at once, each continuing on a different timescale. The old star is gone. But the consequences multiply. This is why the question of what remains is richer than it first appears. What remains after Betelgeuse is not just one object. It is a whole set of aftermaths, a changed Orion, an expanding remnant, newly released material, a possible neutron star or black hole, a scientific archive, a cultural memory, and light still traveling into space. The star dies, but the event spreads into many forms of continuation. That is the opposite of simple disappearance. It is a transformation too large to fit into one ending. And this is where the fear becomes calmer. Betelgeuse's death is frightening because it reminds us that even stars do not keep their forms forever. But it is also calming because it shows that endings are not always empty. In the universe, form changes, matter moves, energy travels, light carries news, remnants grow. The death of one object becomes part of many later realities. The red supergiant will not last, but the material will continue into the galaxy. The final image of this chapter should not be only the missing star, it should be the growing cloud, the darkened place in Orion, the expanding remnant seen by future telescopes, the hidden core, dense and strange, the material moving outward, carrying elements into space. The old red shoulder gone, but not erased, transformed into a long after-image of stellar life. Betelgeuse would leave behind absence, and it would leave behind evidence. It would leave behind beauty shaped by violence. It would leave behind matter that may someday become part of something else. That is why a supernova is one of the most complete endings in nature. It destroys the star, reveals the star, distributes the star, and remembers the star through light and debris. It is death, disclosure, and inheritance in one event. Betelgeuse, when it finally goes, will become all of that. Not just a missing point in Orion, a remnant, a lesson, a source of future matter. A reminder that stars are temporary, but what they make can travel far beyond them. And once we understand what Betelgeuse would leave behind, the final thought is that the star we see tonight may already be gone. Not because we know it is gone, not because astronomers are hiding a secret, not because the star is guaranteed to explode soon, but because the universe never gives us the present of a distant star directly. It gives us light after a journey. It lets us look at Betelgeuse as it was, while the true condition of the star, right now, remains separated from us by hundreds of years of space and time. Betelgeuse may already have exploded, and the light has not reached us yet. This is not a prediction. It is not the most likely statement for any single night. It is simply one of the strangest consequences of distance. If the star died centuries ago, the sky would not immediately tell Earth. For generation after generation, humans would still see the old Betelgeuse, because the old light would still be arriving. The red point would remain in Orion, calm and familiar, while the evidence of the star's death crossed the darkness behind it. That possibility changes the feeling of every clear winter night. A person can stand outside, look up at Orion, and see Betelgeuse glowing exactly where it should be. The experience feels simple. The star is there. The shoulder is red. The constellation is intact. But astronomy quietly adds another layer. What you are seeing is a message from the past. The star that sent that message may still exist, or it may no longer exist in that form. The sky does not tell you which is true until the next message arrives. This makes Betelgeuse feel like a ghost even while it shines. A ghost does not have to mean something supernatural. In astronomy, a ghost can be old light from something that has changed. A star can continue appearing in the sky after its true state has moved on, because light takes time. The universe is filled with these delayed images. Galaxies are seen in earlier ages. Nebulae are seen as they were. Stars are seen from different moments depending on their distance. The sky is full of ghosts made by physics. Betelgeuse is one of the few that ordinary people can feel. That is why the thought is so powerful. If a distant unknown star were already gone, most people would never think about it. But Betelgeuse is familiar. It belongs to the human sky. It appears in one of the oldest patterns we recognize. The idea that such a familiar star might already be physically changed while still shining normally above us makes the sky feel unstable in a quiet way. Not visually unstable, conceptually unstable. It means the universe we see is not exactly the universe that is. It is the universe that has had time to reach us. For the moon, that delay is short. For the sun, it is minutes. For Betelgeuse, it is centuries. For distant galaxies, it is millions or billions of years. Every direction in the sky is a different depth of time, blended into one dark view. Human eyes turn it into a single present, because the brain wants simplicity, but the universe does not obey that simplicity. The sky is not one moment. It is many pasts arriving together. Until then, the question remains open. This uncertainty is not dramatic in the loud sense. Most nights, nothing happens. Betelgeuse shines. Orion rises. People sleep. The world turns. The red star remains a small point in the sky, and the thought of supernova slips back into the background. That is how the universe usually feels. Quiet, repetitive, patient. But under that quiet is the fact that we are always receiving old information from objects too far away to know directly. That combination is what makes Betelgeuse terrifying in the right way. It is not the terror of a monster moving toward Earth. It is the terror of not knowing whether what you see is still true. It is the terror of realizing that a familiar light may be a delayed farewell. It is the terror of understanding that the sky can look peaceful while carrying ancient violence toward us, silent and invisible until the moment it becomes visible. This is why the title matters. Betelgeuse could explode tonight, from Earth's point of view, not because we expect the star to choose tonight, but because the light of an explosion could arrive tonight. That is the careful meaning. It does not mean panic. It does not mean prediction. It means the universe is wide enough that events and observations are separated. A star's death can be old at the source and new to the witness. That is more frightening than a simple countdown. We do not know the arrival. Betelgeuse will almost certainly end as a supernova someday, based on what kind of star it is. But someday may be long after us, or the event may already have happened and simply not arrived. Between those possibilities is the narrow human experience of looking up and not knowing. That is the emotional truth of the video. Not certain doom, not empty reassurance. Suspense at cosmic scale, and cosmic suspense does not need to move quickly. It can become part of the background of winter nights. That slow suspense is different from the way humans usually understand danger. We are built to respond to immediate threats. A sound in the dark, a storm, a fire, an approaching animal, a dangerous road. Betelgeuse is not like that. It asks us to feel uncertainty across light years. It asks us to care about something that may not affect our bodies at all. It asks us to hold a future event that might already be a past event somewhere else. The answer is unsettling. No, not always. Often, what we call the present sky is a layered past. This does not make the sky less beautiful. It makes it more beautiful, because every point of light becomes a traveler. Every starbeam has crossed darkness. Every photon has survived a journey. The light from Betelgeuse has moved through space for centuries to reach the eye of someone standing on Earth for a few seconds in the cold night. The encounter is brief, but the journey was long. The star's old light becomes part of a human moment and then disappears into memory. That is almost impossible to think about without becoming quiet. The light spent centuries traveling. Then it entered your eyes. Then it was gone. And the star that sent it remains unknown in its current state. This is why Betelgeuse feels both intimate and unreachable. You can see it with your own eyes, but you cannot know it directly. You can point at it, name it, Photograph it, study it, model it, compare it, and watch it change in old light. But you cannot escape the distance. The star's present belongs to the star until its light reaches us. Earth must wait. Waiting becomes our relationship with Betelgeuse. We wait without knowing that we are waiting. We wait on ordinary nights. We wait under clouds. We wait while the star is not even visible in the season. We wait while telescopes monitor it. We wait while generations learn Orion. We wait for a message that may not come for a very long time. And if it does come, it will arrive not as a sound, not as a warning, but as brightness. The message will be light. That light would change everything for a while. But even after the supernova, the same rule would continue. The remnant's light would also be delayed. The expanding cloud would also be seen as it was. The compact core, if visible, would also send delayed evidence. Astronomy never removes distance from the story. It only teaches us how to read through it. Betelgeuse would become a different object, but still, one we know through traveling light. This means the final thought is not only that Betelgeuse may already be gone, it is that everything we know about the distant universe is built from arriving photons, arriving particles, arriving signals. The universe does not hand us itself directly. It sends traces. We build our picture of reality from what has made the journey. That should make us humble, but it should also make us grateful. Because somehow, across all that distance, the universe is readable. The light does arrive. The stars do tell stories. Betelgeuse does not speak, but its color, brightness, dimming, spectrum, dust, size, and future all become clues. A giant star, hundreds of light years away, can become part of human thought, because its light crosses the void and our minds learn to listen. That is extraordinary. A dying star in Orion becomes a story told on Earth. The thought that Betelgeuse may already be gone is not meant to make the viewer panic. It is meant to create a deeper kind of silence. The kind of silence that comes when you realize the sky is not frozen, that time is not simple, and that some truths are already traveling toward us before we know they exist. It is the silence of standing under an ancient light and feeling both safe and small. Safe, because Earth will survive. Small, because the star does not need us to end. Betelgeuse will follow its physics whether anyone watches or not. It will burn through its final stages. It will lose material. It will keep changing. Eventually, the core will reach the point where support fails, and the old red supergiant will end. Whether that event is far ahead or already behind the light we see, it belongs to the star's own enormous story. Our part is to receive it. That may be the most human role in astronomy. We receive, we observe, we wonder, we remember. We cannot stop Betelgeuse from dying. We cannot hurry its light. We cannot stand beside it. We cannot watch its true present. But we can look up from a small planet and understand enough to be changed by the thought. We can know that the red star is not eternal. We can know that its calm is delayed. We can know that one day Orion may change, and knowing that changes tonight. Even if nothing happens, even if Betelgeuse remains exactly where it is, even if the supernova is thousands of years away. The sky is different once you understand what you are seeing. The red point no longer feels like a simple star. It feels like an old message from a giant nearing the end. It feels like a quiet warning from the nature of time. It feels like a reminder that the universe is full of events we have not yet received. That is why Betelgeuse is terrifying. Not because it will destroy us, not because it is likely to explode tonight, but because it shows how fragile our sense of now really is. The star could be alive. The star could already be gone. And from Earth, both possibilities can hide behind the same red light. There is no easy way to hold that thought. The mind wants certainty. It wants the star to either be alive or dead, present or past, safe or dangerous, distant or close. Betelgeuse refuses those simple categories. It is alive in the light we see. It may be different in the place it truly occupies. It is safe for Earth, but violent in itself. It is distant in space, but close in imagination. It is a star, but also a clock we cannot read. That is why the story ends not with an answer, but with a view. Orion rising quietly, the belt shining as it always has, the red shoulder glowing above the dark. Somewhere beyond that red light is the true Betelgeuse, hidden from us by centuries of distance. Maybe it still swells in its final phase, unstable but intact. Maybe it has already collapsed, and the light of its death is crossing space at this moment. Maybe the final message is far away. Maybe it is closer than we think. There is no way to know tonight. So we look up, and we wait. Not in fear of the world ending, but in awe of a universe where even a familiar star can become a mystery of time. Betelgeuse teaches that the sky is not a ceiling, not a decoration, and not a simple present. It is a deep field of delayed truths, each light carrying a history, each star living on its own clock, each distance turning reality into memory before it reaches us. One day, Betelgeuse will no longer be the red star on Orion's shoulder. One day, the old light will stop being calm. One day, the proof of a supernova will arrive. And when it does, humanity will not be watching the beginning of the star's death. We will be watching the moment the universe finally tells us that the death happened. Until then, Betelgeuse remains above us, beautiful, unstable, familiar, and unreachable. A red point in Orion, a dying giant in old light, a star that may already be gone. Thank you for watching this calm journey into Betelgeuse and the terrifying beauty of a star that could one day change our night sky. If you enjoyed this documentary, subscribe for more quiet space stories like this. Leave a like if you want more deep journeys into the mysteries of the universe, and write in the comments where you are watching from. Tonight, you were watching the Just About Space channel, talking about Betelgeuse could explode tonight, and it's terrifying. Sleep well and keep looking up. Good night.